So actually, show of hands, how many people have heard of Kaggle? Okay, great. How many have actually participated in a competition or done something on Kaggle? Okay, fewer hands. Okay. Kaggle is the world's largest data science community. We are nearly 2 million, as you might have caught wind of in the keynote yesterday. We span the globe, so we have people coming from all regions across the globe. The community consists of people from a variety of backgrounds, not just data science practitioners, but hobbyists, researchers, academics, and even software engineers and people from all backgrounds. So why are people coming to Kaggle? Why are there 2 million users? Predominantly, we hear it's for learning, sharing, and practicing data science. And they do that by engaging with 3 products on our platform. The first being our competitions. So this is what Kaggle has traditionally been most well known for. This is where companies and organizations host machine learning problems. Second is our kernels environment. So this is our cloud-based data science workbench. People collaborate and create code and notebooks using their data sets. And that brings me to our third product, which is datasets. So this is our open data platform. Currently, we're hosting about nearly 9,000 public datasets that people have uploaded to share and use within their data science projects. So today, of course, because I'm with the competitions team, I am going to focus on competitions. And so, what is a Kaggle competition? So Kaggle hosts supervised machine learning competitions. And at any given time, you can visit our competitions page to see what is live. This is actually a snapshot from several months ago, but I think it gives a nice glimpse at the variety and the types of competitions that we host, from image classification to forecasting, and then this over here on the right is a snapshot of a competition that we had run with Porto Seguro, which is a Brazilian insurance company. Insurance companies commonly run their use cases in this type of an environment. And so they were looking to predict if a driver would file a claim in the next year. And so I'll use Porto as kind of an example of what a competition is and how it's structured. Using that as an example, competitions, the setup is quite simple for a supervised machine learning competition. We work with the host who provides a large labeled data set with a target variable to predict. We work with their data science team to cleanse and prepare the data set for the platform, and then we split it into a training set and a test set. So the training set is what we provide to competitors with the labels or ground truth, and that's what they train their algorithms on to generate predictions against a test set. And that test set is what we use to evaluate and assess the accuracy of the algorithms that are being submitted. And so using Porto as an example, if I grossly oversimplify the data set, perhaps they provided training data, including metadata on drivers' age and income, de-identified and anonymized, of course, and then, of course, the ground truth labels of whether or not the claim was filed. So our competitors join the competition, they download the data, they build their algorithms, and then submit predictions against the test set where the target variable's answers have been withheld. We score the accuracy of those predictions based on an evaluation metric, and then rank those competitors on a live leaderboard. And so the leaderboard ultimately is what results in who receives prize money sponsored by the host of the competition. And it's this competitive dynamic that really kind of fuels people's sort of eagerness to kind of achieve and outpace one another throughout the duration of the competition. And it's ultimately something that we witness time and again through looking at the score progression over time for any given competition. So for Porto Seguro, we saw that over time, the score, the highest leaderboard score, converged on this sort of asymptote or what we consider to be kind of the maximum of what is achievable on that data set and that problem. So now that I've talked a little bit about how the competitions are set up and structured, I want to kind of bring it to life a little bit and talk about some of the common use cases that we witness customers running on Kaggle. And so I'll talk about 4 different use cases and then how the businesses are gaining value through running a Kaggle competition. So the first is sales forecasting. So Corporación Favorita is a leading Ecuadorian grocer. They were looking to better predict and forecast sales of items in their stores. So this is, a classic forecasting problem. As you might imagine, retailers need to get this right. It affects inventory, it affects staffing, and especially when you're dealing with perishable items, where the cost of, shelf life is even, more important. So Favorita provided a series of, very rich data sets that included things like store and item metadata, promotional activities, holidays and events in Ecuador, even oil prices. And then they threw it at the community and said, what can you do to predict unit sales? And of course, at the end of the competition, they were able to receive the winning algorithms. But one thing that we actually find perhaps even more valuable than the winning algorithms is actually the activity that happens on our forums. And so for every competition, there is a discussion and a forum where people are able to share ideas, the approaches that they're taking, methods, techniques, and at the end of a competition, of course, is what their solutions. And so for this type of a competition where it's a feature-rich tabular data set, you saw people doing some creative and clever feature engineering. But one revelation that came about at the end of the competition was a discovery of the use of WaveNet for this type of a problem. So WaveNet was conceived by DeepMind, traditionally was used for taking raw audio waveforms and then generating speech. But competitors found that applying that type of convolutional neural network, the WaveNet, was actually a great predictor of time series data. And so they applied it on this problem, and many of the leading teams were able to make advancements in this regard. So I'm using this as an example to illustrate how people often share breakthrough findings, new packages, novel approaches through Kaggle. And I would even argue that sometimes you can even track sort of the proliferation of different types of these new concepts through their frequency and appearance within Kaggle's forums. So that's our first example. Secondly, recommender systems. So recommender systems very commonly approached in machine learning. For Airbnb, they were looking to predict where a new user would make their first booking. So the reason actually why I'm using this example is it wasn't necessarily for Airbnb about the solutions, but really about the approaches and the people who were attacking their problem. And that was because they came to us running a recruiting competition. And so what we find is that people in our community, as well as customers, whether it's through competitions or jobs board or just forum chatter, are really looking to raise their profile within the data science community. And so we have countless stories of people finding their next job through sharing progress that they've made on Kaggle or using their data science projects as examples in interviews. And so that's the Airbnb example is really about a recruiting motivation. thirdly, I thought I'd touch on another common and rising, sort of rapidly rising use case in machine learning, which is natural language processing. So of course, with the advent of things like Google Home and Assistant, we're seeing a lot of natural language processing interest on our platform. So Google's own Jigsaw team was hosting a competition to help identify and classify toxic comments, and so into actually 6 different subclasses, things like threat, hate, obscenities, that sort of thing. And their mission was to really identify and almost get ahead of negative behaviors in order to promote better online conversations. So really nice, noble mission. And the Jigsaw team was actually very interested in the different approaches that people were taking on this sort of newer area of study. And the things that you might expect out of NLP, like playing around with embeddings or language normalization pre-processing techniques, neural networks, of course, and just throwing as much as they can at a problem. And that's actually something that we commonly see in Kaggle competitions is call it kind of the kitchen sink method, right? Which is all the different techniques that you can throw at a problem. What sticks, what works best, what advances the problem more. And as kind of the title of my session suggests, when you have this largest audience of community members attacking a problem with these brute force techniques, you're bound to find something that works. And that's kind of how problems like this advance. And so one thing that we see is evidence of that through our kernels. So for every competition, there's a discussion or a forum, but there's also a series of kernels that people have shared, so that's code and notebooks, with oftentimes baseline models. And in this particular competition, there was actually quite a lot of kernels shared, and the winning algorithms tended to be some blend of the best techniques that surfaced to the top. Just an interesting anecdote also about this competition is we did some sort of post-competition analysis and discovered that any algorithm that performed quite well on one subtype, one of those subclasses of toxicity, actually performed quite well across all of the subtypes. So there wasn't necessarily a specialist algorithm. They performed well across all subclasses, which was quite interesting. So the last area that is, of course, quite hot in machine learning is image classification, computer vision. To date, our highest prize pool competition was hosted by the Department of Homeland Security, TSA. And so if you flew here or if you've ever flown, you probably run into these scanners. And so what the TSA is trying to do is, of course, detect objects that are cause for threat, and then cause for secondary screening. But of course, when people are alarmed for non-threat objects, so falsely alarmed, that wastes people's time, it causes stress, sometimes people miss flights, and so the TSA is trying to sort of curb that, those kind of false positives, while at the same time not risking passenger safety by missing real threats, right? And so they provided a really nice test data set of volunteers scans to mimic threat objects, and then had people identify whether or not there was an object in each of the zones of a person's body. And the images that they used were actually quite complex and large. There were 2 different formats. There was a 3D format, and then there was also kind of a 2D cross-sectional format. And rather than try to explain to you the winning algorithms and the techniques that were used, which of course you can go to our forums and find out more about, I thought I would use this as an opportunity to share kind of the walks of life and the diversity in the walks of life that people who win or participate in these competitions come from. So of course, you're going to have your PhDs or advanced degree participants who have specialized in medical imaging, have many years of working with computer vision. But interesting anecdote, within our 10 winners, one of them was actually a UC Berkeley freshman. Another was someone who was a data science practitioner, but actually never touched computer vision and just wanted to kind of work with something really cool and foray into computer vision. So, and then lastly, we had a team of just Kaggle enthusiasts. They were data science practitioners, but they've kind of made, I don't want to say a career, but a hobby of working on Kaggle competitions and taking learnings from their prior competitions to feed into this particular win. And so we see that from across all our competitions, across all our participants, is that everyone is kind of converging to really share and learn from one another, and especially in trending areas like computer vision, where advanced techniques might need to be employed. That kind of got mixed up. Oops, sorry, went backwards. So I've kind of covered a few of the classic use cases for Kaggle competitions. What I thought I'd talk about now is kind of where we're headed. Where I'll start with that story is actually Kaggle's broader vision. If you've come to Kaggle lately and you're familiar with our competitions, you'll see that we've introduced these other product areas that I've touched on previously, kernels and data sets. And so what we envision to be is a home for data science, a place where people are not just playing, but actually doing their data science projects, doing their work. And we see that happening by offering a combination of a rich community that's ready to share and learn, data sets where you can do your work, and then an environment where people can create code, reproducible code, and collaborate on that code. So we see competitions moving in this direction as well, to leverage these strengths that we are building in kind of a more genuine way. And so where we're going is towards this concept of code competitions. And so today, the way I described the way competitions are set up today, people are actually submitting predictions on their that their model is generating, models that they're building probably locally, maybe in some cloud environments. But what we envision is that people can actually submit their code. And so we've run a handful of these so far, and we're building towards offering more of these. But an example of this is a competition that we ran hosted by Mercari. And so they are an online marketplace where people sell their secondhand goods. And so they were looking to improve the prediction of prices that were suggested to the sellers of those goods. So what they do is they submit their code within our Kaggle kernels environment. They can collaborate with teammates by sharing that code with those teammates privately. And then they submit the actual code rather than just the predictions to that code. So what you can imagine is that for the customers in the equation, they're receiving the code that was used to generate the submissions in a more reproducible environment. They can also run that code on a truly held out test set. And then for our community, they're able to work in an environment that enables them to truly collaborate with one another. And so this is all kind of moving towards our goal of really being a place where people can share and learn from one another by creating an environment for them to do so. And so that kind of is our vision for where we're headed in competitions. So What I'd like to do now is actually kind of step you through a live example of a competition. And so I'll start my demo portion. So this is our competitions listing page. Any user, you sign up for an account, you can get access to this. What I thought I'd do is just kind of show you, so this is just today, right? The active competitions we have going on. We have a series of featured competitions, and these are the ones that are typically hosted by commercial organizations or companies who are looking to receive the solutions for each of the challenges. They post, what their prize pool is, as well as, the summary of what they're trying to solve. Below those, we have a series of getting started competitions. So your classic MNIST and Titanic competitions, we refresh these so people can continue to work on those and learn, especially if you're getting started. And then followed by a series of research and playground competitions. So you can see that a series of these playground competitions are using our new format of code competitions. So what I thought I'd do is actually jump into, this isn't necessarily a featured competition, but it's a competition we launched about a week ago. And it's being hosted by the Inter-American Development Bank. And they are trying to improve the prediction of poverty levels within a country. So in this case, it's Costa Rica. And they're doing this because they use that as a way to assign social welfare need and these types of programs. When it loads. Okay, so this is the live competition site. It gives a little background of what that host is trying to achieve. It gives an overview of the evaluation metric we're using to score the submissions. And so we have kind of a library of these evaluation metrics. And we work with the host to identify what they're trying to emphasize, what they're trying to de-emphasize, in order to come to an evaluation metric that makes the most sense for that problem. We have prizes. In this case, it's just Kaggle swag. We're not, this is considered sort of a for good challenge, and therefore we're not looking to award prize money. And then timeline associated and any important dates. The data itself is accessible through the competition's data page, and we've added some new features. The data, of course, can only be downloaded after you've accepted the competition's rules. And we have added a new feature down here around, we call Data Explorer, and it gives people kind of a glimpse at what the data for a given data set looks like. And so you can download that data once you have accepted the rules for the competition, and then you can use it to train or test your algorithm's performance locally or in a cloud environment. As I mentioned before, there are kernels for the competition. So these are completely organically generated by our community. Oftentimes they range from exploratory data analyses, so people looking at the data and what features appear to have some importance, and they'll share their notebooks that do that type of exploration and plots. And then within kernels also is, of course, some often basic baseline models as well. Our discussion pages is where people share anecdotes about the approaches that they're taking, the types of features that they're trying to explore, if they want to team up on a competition, and that sort of thing. And then the leaderboard is, of course, the ongoing tally of how people are performing. Competitions typically last, 2 to 3 months, and at the end of the competition, those in the winning spots will receive the prizes. The other thing that I thought I'd share in this context is an actual kernel model. So I'll do that actually through another competition that I can highlight. We just actually launched yesterday because I know that we have a starter kernel that we've created. So for this particular competition, it's using actually a public BigQuery data set, New York City taxi data, which includes kind of the origination point as well as the endpoint for a bunch of different taxi fares, and then the corresponding fare for that ride. And so the idea is to create models that will predict what the fare will be based on that data. And so we just launched this morning, or last night, and so we're still kind of gaining some teams here, but we did create a kernel that that uses kind of a simple linear model, and so you can kind of see what one of these looks like that actually generates a solution. What he's done is he's done a very basic look at the kind of distance between the 2 points, between the start and end points, and then taken a look at using that as a way to generate a model for how to predict the fare. And this type of a very basic approach, I think, gets him an RMSE value of, so that's root mean squared error, which is the evaluation metric used in this case. So it'll get that RMSE value of maybe around $5 or $6. But what the competition is hoping to help people do is make advancements using other techniques. And actually this was hosted in coordination with Coursera, who is offering a course that's kind of helping people use TensorFlow to work on this type of a problem. And so what this does is it generates an output submission that can be used to be submitted directly to a competition. For sake of quickness, I've gone ahead and forked that same kernel and rerun it, commit it, in order to be able to show sort of how you might take the output of the kernel and then submit it to a competition for evaluation. And then what that does is that immediately generates your score and then places you on the leaderboard for that competition. So that's kind of the summary of how a competition works, what we're doing, different types of use cases that we're solving for customers. Okay. Well, thank you all very much. Have a great day.